Greetings and welcome to my new calculus channel. My name is John Gabriel. So, in the previous video, this one here, we looked at why your mainstream calculus is a load of bullshit. And that was part one. Okay, and we talked about 6 reasons, and I covered the first reason, which is the most important reason, that the definition is circular or self-referential, which one must know is never a good way of defining any concept. You simply cannot define a concept in terms of itself. Okay, that doesn't make sense because it must be defined in terms of other concepts that are already known in meaning. So, not to spend too much time on that, the second big problem was Cauchy's original it's actually part of the first problem, but his derivative definition was simply reworked in terms of different language. So, what does that mean? It means that Cauchy's definition is still the same, and the one that Weierstrass came up with, the inequalities, simply excludes things like infinitely small, infinitely smaller, etc. So it just takes out the bothersome terms. But exactly the same thing happens, okay? So, and Cauchy makes one very big mistake. He says the function must be continuous. And by the way, he assumes that property. But continuity is not sufficient to do this kind of reasoning that you see in MD here. You need smoothness to do this, okay? You cannot do with only continuity. So a function must be smooth to play his silly game of deception, or it's just plain stupid. So mainstream mathematics academicus, it's actually meant to be academics here, who are actually non-mathematicians, people with PhDs in math, assume that a function is smooth when they use the epsilon delta definition. If it's not smooth, you can't use the epsilon delta definition, okay? And Cauchy's definition still prevails in most mainstream thought. So why can't you, first of all, why can't you use this definition if the function is not smooth? You want me to tell you why? Let me show you. Okay, let's pull up a little, little paintbrush. So if you have something like this, okay, and you try to take a finite difference like that or like this, it's not going to work. It has to be smooth, okay? It has to be smooth. There cannot be any kinks in the function. So continuity is insufficient, all right? Now, Cauchy's definition still prevails in most mainstream thought. For example, dx means a little bit of x, which is just outright nonsense. It's a type of gibberish that one can expect from an MIT PhD in mathematics, and the same drivel is carried over into the definition of definite integral. So at the end of this article, which you also have a link to, is a short discussion with Anthropic's Claude AI. Now, the next point I want to cover is that there is no such thing as a real number, okay? A real number is a bogus concept because to be a number, the object has to be a name that is given to a measure that describes a ratio of magnitudes. So a real number doesn't do that. Okay, so there's no such thing as real numbers. And if you're wondering about Diedekencuts and Eudoxus, real numbers, etc., they're all invalid garbage. And here in this article, I give you a description of why Diedekencuts are a load of BS. So mainstream math academics know that they do not understand and have no alternative. So for this reason, they will say that the finite difference approaches some real number. In other words, 0 over 0 suddenly becomes some real number, which is absurd because if a real number were real, it would equal to rise over run. But there is no rise over run, not even in the case where the tangent line slope is what is known as a rational number. It just simply doesn't exist. Okay, so in the next video, we'll talk about what's happening with the so-called definition and how their definition, in other words, this IDE, and why they use it. So I've given you a lot of information here, and I'll continue in the next part 3 to talk more about that. My name is John Gabriel. If you're not already a subscriber, become one, follow me on academia, click like, and if you want to get access to stuff that I don't share with the public, join. This is, you go to any of my videos and you click join. For a mere €5 a month, you have access to incredible information, okay, which you normally will not get here on YouTube. This is a new calculus channel. Till next time.